the award for dams, the Split Rock Reservoir Dam Rehabilitation in Rockaway Township, New Jersey. The Split Rock Reservoir Dam is a Class 1, high-hazard, cyclopean concrete gravity dam with a maximum height of 39 feet and an overall length of approximately 482 feet, according to NJDEP Safety Standards NJAC 720. The dam was constructed in 1948. Split Rock Road, a 14-foot wide paved roadway, transverses the 18 feet wide crest of the dam. A 50-foot wide uncontrolled overflow spillway is traversed by a 2-span bridge. 6 30-inch by 30-inch sluice gates are located within a concrete intake tower on the upstream's face near the midpoint of the dam. Water enters the tower through the open gates and exits through a 36-inch diameter cast iron pipe, which acts as the low-level outlet and is used to lower the reservoir during emergency situations and to provide conservation flow downstream of the dam. The dam structures had deteriorated and fallen into serious disrepair, requiring remedial measures to avoid further deterioration and the possibility of a dam failure. Hydrologic and hydraulic analysis determined that the spillway was inadequate, causing the dam to be overtopped during extreme rainfall events. This was addressed by raising the top of the dam to provide additional flood storage and prevent overtopping, and was accomplished by construction of new reinforced concrete retaining walls on both sides of the roadway. We see here concrete is being pumped into place. We can also see the new dam wall well underway. The top of the 482-foot long dam is being struck off and finished. We can see the curing membrane in place over a previously placed section. The existing dam structures were primarily composed of unreinforced concrete and were designed for 1946 loadings. Present New Jersey DEP dam safety standards require higher design loadings for ice load and seismic loads, while the barrier had to be designed for AASHTO vehicular impact loads. In order to enable the dams to be rehabilitated to meet these greater design standards, reinforced concrete was chosen and designed to carry the higher design loads. Approximately 1,500 cubic yards of cast-in-place concrete was placed as part of this project. The materials were selected in lieu of precast concrete due to the flexibility of the material and the requirement of the material to be able to adapt to the existing varying conditions of the historic dam and existing bedrock. Concrete construction included the following. A New Jersey DOT Class A mix was used for most concrete. Since the dam was a prime target for vandalism and graffiti, a graffiti-resistant coating was specified, which would also create a uniform finish, concealing the honeycombing, scaling, and the various concrete repairs on the existing concrete. The color of the coating was approved by State Historic Preservation Office. The project is nearing completion here. The decorative award winner this year is the modern North Tower Rooftop in Fort Lee, New Jersey. The Modern is an extraordinary luxury residential development highlighted by 2 47-story iconic towers rising up in the center of Fort Lee, New Jersey. The Modern's all-glass towers will each contain 450 luxury rental apartments featuring a mix of studios, 1, 2, and 3-bedroom residences that offer spectacular views of the Hudson River, New York skyline, George Washington Bridge, and the surrounding landscape. The 57,000 square foot rooftop landscape and hardscape installation is located on the roof of the North Tower's 5-level parking garage. The hardscape scope of work includes the installation of concrete pavers, IPE wood tiles, precast curbing, and a decorative concrete walkway. All concrete pavers and IPE wood tiles are installed on pedestals to create remarkable rooftop, patio, and boardwalk areas. The landscape includes the installation of fiberglass planters, irrigation, lightweight topsoil, plant material, and expansive rolling lawn area, when additional outdoor amenities like a spectacular infinity pool surrounded by chaise lounges, individual and community barbecue stations, and volleyball, basketball areas, it creates a luxurious and beautiful outdoor space for enjoyment by residents. We see this creative landscape at one end of the rooftop. Wood tiles lead us past a very interesting area. This shot shows a conventional seating area with planters, and our final view shows a beautifully conceived landscape with multiple concepts. The educational award-winning project this year is Montclair State University New School of Business. The New School of Business is a 6-story, 143,000 square foot structure located adjacent to University Hall. The facility will house instructional spaces, administrative offices, conference and seminar rooms, departmental suites, group study rooms, large common lobby and lounge spaces, a cafe, and an open surface parking lot. The lower level of the building houses academic classrooms and a limited amount of parking. A separate entrance from the covered parking area brings visitors to a lobby that provides elevator access to the floors above and a master staircase which leads to the cafeteria or the building atrium on the first floor. Cast-in-place concrete was used for the foundations and all the slabs supporting this unique structure. Floors 3 through 5 incorporate a mix of academic offices and classroom areas clustered into distinct zones and separated by department offices and seminar and conference rooms. The design of the building complements and draws from the Spanish mission architectural design vocabulary used in University Hall. The building will exemplify the university's commitment to sustainable design and its intent to achieve a Silver LEED rating. Audiovisual and technology systems shall be designed as an integral part of the building's infrastructure to help support the teaching curriculum. The high-rise winning project this year is the 70 Columbus Tower in Jersey City, New Jersey. It has 33,000 cubic yards of cast-in-place concrete. It is a 50-story, 520-foot high residential tower and the first phase of a 3-phase project. Lateral stability is provided with a box core and wing walls that extend to the building perimeter. A partial hat truss wall at the top reduces the deflections to acceptable levels. Concrete strength in the shear walls and columns varies from 10,000 psi to 6,000 psi, with the slab concrete varying from 7,500 psi to 5,000 psi. The building is supported by pipe piles filled with 4,000 psi concrete under 6,000 psi pile caps. We see a corner view up to the 15th floor. 3 columns are walked between the 15th and 18th floors to extend the floor plate and provide larger living spaces on the upper floors. We see the building at the 30th floor. A cantilevered slab extends the floor plate on the top 5 floors. The 35-foot tall cantilevered column and beam frame forms the top of the building. The versatility of high-performance cast-in-place concrete is on display here. The innovative design and construction winner this year is a Newark Bay Bridge deck replacement. The New Jersey Turnpike's Newark Bay Hudson County extension is one of the most vital links in the region's complex transportation network, linking busy I-95 to New York City and the Port of Newark. The goal of this $140 million project was to replace 1.5 miles of existing concrete deck on 4 lanes and 2 shoulders, while maintaining 2 lanes of traffic in each direction. The team was required to reconstruct the bridge in 39 months, including 12 months of consecutive night and day construction. 5 construction stages were utilized to maintain consistent levels of service during all phases of construction. Construction is underway in this photo. The rehabilitation project encompassed demolition of 66,000 square feet of existing composite deck slabs and replacement with 1,753 individually designed high-performance concrete precast deck panels. Some of the pioneering features of the precast system included casted high-strength steel shear stud pockets, haunch grouting tubes, and PVC cross-dowel tubes. Bridge deck panels were installed using a gantry crane rail system or a 180-ton crane and were easily hoisted utilizing built-in lifting bolts. The concrete panels were placed and adjusted to grade using leveling bolts and were set using a fast-setting, high-strength methacrylate grout system. The PVC cross-dowel tubes and joints between each panel were also grouted in order to link the panels together as one deck surface. HPC closure pores were placed at every spanned end. Additional contract work included installing a catch shielding system over water, repairing structural steel, placing HPC parapets, installing new steel deck joints, placing new HPC concrete approach slabs. High-intensity construction cycles were performed during weekend hours to prepare the extension for increased traffic volumes resulting from the programmed Pulaski Skyway reconstruction. The high-performance precast slabs were heavily reinforced with epoxy-coated bars. The majority of the existing deck was replaced with precast deck panels. In addition, an LMC overlay was placed at the existing shoulder of the main span, and cast in place HPC closure pores were used to complete each end of the span. HPC precast panels were selected in lieu of traditional cast-in-place method. Let's look at the innovative aspects of the project and concrete use. Innovative aspects of the project or concrete use. The use of precast concrete panels versus traditional cast-in-place method resulted in accelerated completion of construction, including placement of deck panels during winter months, better quality control to ensure optimal temperature and humidity for concrete curing, minimize cracking due to completed concrete cure time, increased service life with permeability admixture, a smoother riding surface with controlled leveling and micro milling. Here is traffic proceeding at normal speed on high-performance concrete surface. Our final overhead shot is of a successful restoration of a very important bridge. The Military Parks winner this year is Veterans Memorial Park in Neptune, New Jersey. Exposed reinforced concrete was used to complete the Veterans Memorial walls and planters. This great-looking project had a complexity of tight radius walls with angled sills, as well as its honor to the men and women in the U.S. military who reside in Neptune Township, who have fought and are currently fighting for our country. We see these walls prior to concrete placement. This project will be a gathering for all to attend to view placards of the heroes of the Air Force, Army, Coast Guard, Marine Corps, and Navy. We see the architectural concrete walls well underway. Each branch of the military has its own wall and planter with the branch insignia as puzzle-like pavers on the ground. We see the Army area here. There is also one large gathering space that has a wall etched with the following quote: "The willingness to sacrifice is the prelude to freedom." This corner shot confers the excellent cast-in-place concrete. This memorial park is dedicated with appreciation to the men and women of Neptune Township whose loyalty, service, and sacrifice during times of war and peace define the character of this great nation. Our final picture is of this great award-winning project. The Merit Award winner for parks this year is the concrete walkways and site work at Forest Edge area, Homedale Park, New Jersey. Homedale Park, located at Longstreet Road in Homedale Township, is one of Monmouth County's busiest parks, with nearly 1 million visitors annually. The 565 acres regional park hosts a variety of recreation opportunities. The Forest Edge area of the park includes group picnic facilities, a playground, and links to a paved recreation trail. The pedestrian connections between the parking area, restroom building, and playground were old and non-compliant with current Americans with Disabilities Act. The project goals included removing the existing walkway stairs, creating pedestrian links, and creating a patio mode with seating central to the site. Challenges include elevation change of up to 18 feet between the accessible parking area and restroom building, avoiding an existing septic field at the center of the site, and respecting the existing trees that enhance the site. This view shows the elevation change from the parking level to the restrooms. The center section used brown concrete. The curvilinear design solution employed long sweeping curves to achieve the proper lengths for a less than 5% slope for ADA compliance. Concrete is a perfect material for constructing curvilinear walkways. Additionally, because of its versatile use as a construction material, i.e. pavement, stairs, and curbing, concrete proved to be very cost-effective. The use of colored concrete with exposed aggregate was used to embellish the central patio and main stair landing. This section of sidewalks is complete. The elevation change is obvious here. This gently sloping sidewall leads us to restrooms. Our final shot shows how great new concrete has significantly upgraded this beautiful park. The repair and restoration winner this year is the JFK Memorial Bridge superstructure in Egg Harbor Township, Atlantic County, New Jersey. The John F. Kennedy Memorial Bridge is a 25-span, 1,320-foot long structure spanning Risley Channel, which leads directly into the Atlantic Ocean and provides a main thoroughfare for residents and vacationers between the mainland and the island communities of Longport, Margate, and Ventnor along New Jersey's southern coast. The bridge was dedicated in 1963, and after 50 years of service in the harsh saltwater environment, the bridge fell into a state of disrepair. However, since the bridge also serves as an emergency evacuation route from the island communities, closing the bridge to all vehicular traffic for repairs was not an option logistically, nor was a total replacement of the structure an option financially. With that in mind, it was decided to commence an aggressive rehabilitation program to restore the most seriously deteriorated bridge elements, with the ultimate goal and challenging of extending the service life of the bridge by a minimum of 25 years. The majority of the methods chosen to repair involved specialized and innovative concrete-based materials. The placement of these materials proved to be a challenging task and took careful coordination and planning when the temperature and other restrictions associated with the materials were combined with the logistical restrictions of the project, such as not interfering with the vacation season, not allowing permanent lane closures during construction, and environmental permit restrictions. More than 1,600 square feet of Type B deck repairs were completed using a methyl methacrylate acrylic, MMA, primer and fast set patching materials, and new deck joints were installed at all 24 piers and both abutments, installing them for one half of the bridge at a time using an elastomeric concrete product. Both of these products, although labor intensive, were beneficial in that they set up quickly and allowed vehicular traffic to be run on them within only a couple of hours. We see that here. This material has been used previously on only a few bridges in New Jersey and is 3/8 of an inch thick. MMA alleviates the designer's concern of the bridge's inability to accept the additional dead load from a traditional overlay. The bottom flange of many of the precast concrete I-beams were extensively delaminated and spalled. Many locations exhibited several rows of exposed or damaged steel reinforcing strands that compromised the structural capacity of these beams. Therefore, after requiring the damaged areas to be patched with a high-strength cementitious concrete product using traditional methods, it was also specified that these beams would receive a carbon-reinforced polymer fabric wrap which would restore the beam strength. In total, more than 3,200 lineal feet of this repair was required. The first 8 piers from the west are constructed of a reinforced concrete pier cap supported by wooden piles. While all 112 piles exhibited some deterioration, more than half of the piles had 25% or more section loss. After the most severely deteriorated piles were repaired with a full section splice, all of these piles were wrapped with a 10-foot section of carbon fiber mesh surrounded by a fiberglass jacket. Finally, an underwater cementitious-based non-shrink grout was pumped into the jacket until it was filled, which completed the repair and restored the capacity of the piles. The rehabilitation project avoided a costly replacement project and the inconveniences that come with it, while also protecting the safety of the public. This is the fully restored bridge deck, which allows everyone to enjoy the Jersey Shore. The residential award winner this year is the Monarch structure in East Rutherford, New Jersey. This project consists of two 4-story, U-shaped residential towers over 2 levels of parking garage. The first residential transfer level is a multi-use floor measuring nearly 150,000 square feet, serving mainly a residential occupancy with varying dwelling units, an outdoor pool located between the 2 towers, and various tenant amenities. In areas where the towers occur are composed of 14-inch thick flat plates to support both the vertical and lateral loads of the wood structures. We see that level. Where the towers are 10 feet cantilevered from the facade of the building below the transfer floor, 3-foot concrete beams with relatively heavy top continuous bars and closed stirrups are required to support the wood structures. We see the heavy slabs and beams here. The outdoor swimming pool, measuring 22 feet wide by 70 feet long by 3.5 to 5 foot deep, is also constructed with reinforced concrete. The upper parking level is also 115,000 square feet and is a flat plate with 12 to 11 inches thick spanning between columns, shear walls, and perimeter foundation walls, and with 10.5 to 9.5 flat plate spanning between pile caps at the ground floor. The front planters' concrete walls are supported on cantilevered grade beams stemming from the buildings to eliminate the use of pine. The retail winning project this year is the Oceanport Village Center in Monmouth County, New Jersey, in the borough of Oceanport. The Oceanport Village Center development is located at the northern corner of East Main Street and Potopac Avenue near Monmouth Park Racetrack. The total site contains approximately 4.7 acres, including a public right-of-way to the north of the site. The site was vacant land utilized as a soccer field with associated parking areas prior to development. The site is bound by existing commercial developments to the north, open space to the east, Potopac Avenue to the south, and East Main Street to the west. This project is a mixed-use retail, office, and residential development with associated off-street parking facilities and utilities. Part of this project includes a new public roadway and the streetscape of East Main Street, upgraded with new curbing, sidewalks, and parking areas. The new curb and pavers are visible in this photo. Concrete was utilized for the building foundation, slab, column footings, trash enclosure slabs, sidewalks, Belgian block curb base, reinforced concrete pipe, and vaults for stormwater detention. Over 1,500 cubic yards of concrete were used in the project. High strength, 6,000 PSI concrete was used for the structural foundations of the building. 4,500 PSI concrete was utilized in most other areas. The pavers are going in this photo. The complex is really coming along well, as we see. Our final view of the completed project is at the corner, and a new beautiful walk area is clearly highlighted. The streetscape winner this year is for the City of Union, Hudson County downtown revitalization of New York Avenue. The city has been incorporated for 100 years, and the surface roadway, curbs, and pedestrian sidewalks and ramps have sustained extreme wear and tear. Not only did this affect the functional and visual continuity of this main thoroughfare, but haphazard access to businesses, poor integration of business properties with public spaces, aging streets with patched asphalt, eroding curbs and sidewalks, and intermingling of conflicting styles along the 2.15-mile-long business district combined to make an unfriendly pedestrian environment that adversely affected businesses and was not conducive to private investment. Two views confirm these conditions. In 2012, the city embarked on a major reconstruction project for the entire New York Avenue corridor, one of the main thoroughfares connecting the northern and southern regions of the city. This section of New York Avenue is a mixed commercial and residential neighborhood, providing access to schools, City Hall, the Bergen Line Commercial District, transportation, and community parks. The overall revitalization project included the reconstruction of 43 city blocks from 2nd Street to 48th Street. Phase 4, the final stage of the project, entailed the city's replacement of all curbing and sidewalks and repaving the roadway between 32nd and 48th Streets. 43 city blocks was a major challenge. Concrete was utilized to construct the curbings, light foundations, sidewalks, and driveways. The city installed new decorative sidewalks throughout the project, which consisted of London Score concrete with a 2-foot by 3-foot wide red stamped concrete sidewalk. The concrete used was an approved standard mix that would perform well, having a long lifespan in this heavily traversed thoroughfare. A concerted effort was made to improve the continuity for pedestrians both functionally and aesthetically by tying in the new sidewalks into existing entryways. Decorative stamped concrete in brick red to match the other project phases was integrated into existing frontages to businesses, side streets, schools, crosswalks, and park entrances to visually unify them while promoting pedestrian activity. Stamped concrete is a quick and a cost-effective means of getting the most aesthetics for the cost, which enabled the city to be able to use it throughout such a large initiative. This is a typical bump-out detail. The total project involves 8,600 cubic yards of concrete, with Phase 4 utilizing 3,000 cubic yards. The final stage caps well over 2 years of major reconstruction projects for the city. Completing a job of this size is a critical element in enabling the city to function better and more safely for residents, visitors, and existing commerce and services, while promoting growth that is critical to the health of the city's economy. It has also prompted many existing business owners to make storefront improvements. This is one great transformation. The most significant factor in helping the city achieve these goals was its use of concrete, improving downtown aesthetics with a contiguous network of roadway and sidewalk networks that can sustain a high level of pedestrian traffic, created a connectivity that invites the infusion of private investment, which in turn revitalizes the city's economy. Here is a typical corner and sidewalk in a residential area. Versatile concrete and the City of Union combined for a remarkable rebirth of this area. Our final shot shows the completed high-performance concrete interchange.
The Merit Award winner for transportation is the New Jersey Turnpike Interchange 6, Mansfield, New Jersey. This exciting project included construction of 7 new bridges, the widening of 1 existing bridge, 24 retaining walls, 17 sign structures and fountains, which are all located within 1 mile of New Jersey Turnpike roadway in Mansfield and Columbus, New Jersey. The new bridges are both curved and tangent structures, with the longest span over 1,133 feet. These bridges are supported on a combination of hammerhead, twin pedestal, and multi-column concrete piers. Foundations consist of predominantly uncast 6-foot and 8-foot diameter concrete drilled shafts reaching depths of up to 150 feet depth and concrete-filled pipe piles. Approximately 35,000 cubic yards of various concrete types were placed to complete this project. Concrete speed is a great advantage of concrete for the various project elements. Drilled shaft construction was limited to a 36-hour window from start to finish for each shaft. The production times at which precast concrete MSE walls are erected is unequaled. The building platform for the construction equipment rises as the wall rises and backfill is completed. Additionally, concrete offers advantages for construction access. No matter what the size or shape of the finished product, concrete can be pumped through 5-inch pipe to create it. By constructing bridge decks on this project of high-performance concrete, the concrete serves both as a sophisticated wearing surface and a durable structural member. Forming methods include form pour strip, stay in place, slip form, and polymer slurry shafts. For speed and economy of construction, an on-site slurry plant was engineered and serviced and drilled shafts on the project. Construction spanned through all seasons for multiple years, requiring both hot and cold weather concrete practices. Substructure elements also invoked the application of mass concrete procedures. Another large aspect of the project required the retirement of 4 existing bridges. An on-site crusher processed the old concrete sub and sub-superstructures for reuse in roadbeds on the same project. With this environmentally friendly practice, the life cycle of the raw concrete material outlasts the functional lifetime of the structure it was originally used to create. Precast was used extensively for mechanically stabilized earth walls and barrier sections, which are precast in New Jersey. Over 180,000 square feet of precast product arrived by truck and ready to place. The production of wall panel erection and the decreased footprint of the other large wall structures at bridge approaches were big advantages. Precast concrete was also used for buried electrical and drainage systems. Just like the foundations that remain unseen by the end user, all of these precast elements form an indispensable part of the modern transportation network that is vital to all aspects of our economy. Our final shot shows the completion of the concrete structure.
The warehouse winner this year is the Super Flat Warehouse Edition in Dayton, New Jersey. These slabs were placed and completed in the open summer of 2014 prior to the building being erected because of a rack-supported structure design fastened to the slab. We see the vapor barrier has been placed in the lane. There was 121,000 square feet of 12-inch reinforced aisle rack slabs placed and finished to an FMIN 100 tolerance. We see the rest of the addition. The laser screed is striking off this narrow strip. This slab was a 2014 Golden Trowel Award winner at the World of Concrete for defined traffic narrow aisles. We see the final troweling. Our final look is at this FMIN 110 floor. It certainly is super flat.